morning, students. I hope you have tried out the questions that I mentioned before, questions 6 and 7. Okay, it's particular application of moments, but what we have now is actually 3 force, okay, instead of the usual 2 force that you see. Okay, so now we have actually 3 forces. The approach is actually the same as the previous one. So what you do actually is you identify the clockwise moments and group them one side, identify the anti-clockwise movement and group them on the other side. If it's balanced, both components will actually be equal to each other. You equate the both clockwise and anti-clockwise together, and after that you use your algebra to solve. Same problem again, to identify the clockwise moments or anti-clockwise moments, the common hurdle will be identifying the correct perpendicular distance. Okay, so that would be one of the common thing that you see in your approach. Okay, the concept and the common problem. Okay, for this one, let's take a look. Okay, you have 2 forces on the right. Okay, F is pointing downwards. This, with respect to the pivot, this will actually give you a clockwise moment. Okay, 6 Newton will be a clockwise moment also. Okay, same thing if you look at the rod. Okay, if it's pivot at the center, I have a force on the right side push down. My rod will actually rotate clockwise, and this is how I know these forces generate a clockwise moment. So for my other forces, what we have here is this. Okay, for my 10 Newton, if I push down on the left side, you will find that I will actually generate an anti-clockwise moment. So if you look at all the 3 arrows here, you'll find that the 2 purple one, the clockwise moment, what you're going to do is you're going to find the respective D perpendiculars, find the respective moments. After that, the next step you need to do is you group them together. Okay, so let's look at the moments. Okay, let's look at the respective perpendicular distance. For F, the perpendicular distance will be measured from the force to the pivot itself. Okay, so same thing, look at the 3-step approach of finding perpendicular distance. Okay, if you forgot, you can look at the video 5.1 or 5.2 which I made earlier. Okay, so if you've done the 3 check, you'll find that the perpendicular distance for DF is actually 2 meter. Okay, for 6 Newton, you look at the perpendicular distance for 6 Newton, it will be from the 6 Newton line of action of the force measured to the pivot, and that will be the D perpendicular for D6, which is, according to the picture, is actually 4 meter. Okay, so 4 meter is actually the perpendicular distance for D6, not 2. Okay, so take note of this. So students, take note, D6 perpendicular distance for 6 Newton is actually 4 meter. Okay, so for this we will actually more or less work out what is the respective components for the clockwise moments. How about the anti-clockwise moment? Okay, let's look at the perpendicular distance. Okay, same thing, is measured from the line of action of the force, okay, to the pivot. Okay, the shortest distance between them, this will be by D perpendicular. Okay, my shortest distance between them, okay, this will be my D perpendicular, which happens to be 4 meter. Okay, so this will be my perpendicular distance for the anti-clockwise. So once you have it, group them together. Okay, moments formula like I mentioned before, is force equal moment equal to force times D perpendicular distance. Okay, then after that you go about doing the answer. Okay, so now let's group the moments together. Okay, so here what you do is you apply the principle of moments. Okay, sum of anti-clockwise moment equal to sum of clockwise moment. Okay, here students, you need to take note. One of the common mistake that you make is when you write down principle of moments, the clockwise and anti-clockwise, the next step or the next working you actually shown is actually what we call, it doesn't tally with your presentation. For example, on the first line you look at, this is sum of anti-clockwise moment, but when you look at your presentation, the next step you are actually finding the sum of clockwise moments. Okay, so there is a mismatch of your presentation. You are looking for sum of anti-clockwise, but the next step you actually give me the sum of clockwise moment. Okay, so there's a mismatch of presentation. This one you have to be very careful, because if there's a mismatch of presentation, the working will not be logical. So it will be rendered as a careless mistake, and your whole concept or your whole answers will be flawed and you'll be marked wrong. Okay, so for in this case, the presentations, we will still stick to the presentation. So you have a sum of clockwise moments, which is equal to the sum of anti-clockwise moment. Okay, so in this case, the clockwise moment you are looking out for, there's 2 components, F and as for the clockwise movement, okay, clockwise movement is quite straightforward. For the anti-clockwise movement is quite straightforward. There's only by the 10 Newton force, and the perpendicular distance given by the question is actually 4 meter. Okay, so once you have the equations, then you you can use your algebra to solve. Okay, you will find the F with a simple 8.0 Newton. Okay, for O level, Cambridge O level, take note, in your calculated answers, all your final answer, all the answer must have units. The final answer that you give, okay, to the marker, it must have unit, and it must be 2 or 3 SF. So for example, the number 8 here is a perfect number, but you still have to put a 0.0 at the back because the answer that we accept is actually 2 or 3 SF. So just take note of this, a small requirement that is required in the exam. Okay, so but the more important thing is the concept. Okay, so same thing, you have 3 forces, you generate 3 moments. What students you need to do is you group the moments accordingly, either clockwise one side, anti-clockwise the other side. Okay, so common hurdle, make sure the units is in meter, and you make sure you group the right moments at the right place. And the last one is the most important one, you make sure the perpendicular distance you chose is actually the correct one. Okay, run through the video. If you run through the video again, if you're still confused about certain things, okay, certain approach. Okay, if not, if you are okay with it, we can move on to question 7, which is an interesting question. Okay, you have, most of the time we see only one rod or one ruler, but right now you actually see 3 rods being hung on 3 different strings. Okay, the approach for this type of questions, or the interpretation of this type of question, you have to be careful. Okay, because if you can't interpret the questions, you actually can't start to solve. Okay, so for this type of question, the important thing you have to take note is that the loads are slowly building up, meaning the load at the lower tier, okay, the load at the lower tier, okay, will be borne by the strings just at the upper layer, which means if I'm looking at 2 newtons on the left, 1 newton on the right, so the total weight I'm looking at this layer here, it will be 3 newton. So 3 newtons, although I have 2 newton on one side, 1 newton on the other side, all the weight will be experienced by the weight, or all the weight will be experienced by the line at point A, with the string at point A. So at point A, effectively I'm saying that there is actually a force of 3 newton weighing down on it, and based on the layer, this 3 newton actually comprises of 2 newton and 1 newton. Okay, so take note of this. So the same thing will happen on the second layer, on the right side. The lower layer, you have a total of 1.5 newton. Okay, 0.5 newton on the left, 1 newton on the right, and the total of 1.5 newton will be experienced by the string at point B. So this is effectively saying that there is actually a weight of 1.5 newton experienced at the left hand side. Okay, so take note. Okay, once you look at how the weights are being loaded up, okay, are being distributed or loaded up at different layers, now we'll look at the moments. Okay, now at this question here we have 2 layers. At the lower layer here there is 2 rods, so we look at the rods at individual section. Okay, let's look at it at different color. So now at the lower layer you'll find that it's actually comprises of 2 newton, 1 newton, and it's balanced across, or is hinged across a pivot at point C. So which means that at the 2 newton force will actually generate a moment about the pivot C, and based on the pivoting and based on the force pulling down, 2 newton force will actually generate an anti-clockwise moment. Okay, the same thing if you look at it on the other end. Okay, the rod that you have, the second rod on the right side, you'll find that the 0.5 newton on the left side of the rod will actually weigh down, and you also will generate an anti-clockwise movement, okay, on the rods about the pivot here. If you look at the 1 newton, okay, and the rods, 1 newton, let's say we look at the rod on the left side, the 1 newton will actually generate a clockwise movement, okay, about the pivot C, and similarly the clockwise movement by the other perpendicular, by the other 1 newton. Okay, so when you look at it, you actually looking at 2 clockwise movement and 2 anti-clockwise movement. But to solve, or the approach to solving this type of question is actually to identify the set of pivot, a set of moments separately. Deal with it separately, don't combine. So what you are going to do is you are going to look at the left side of the rod, the aeroplane and the car one, this side, separately, or to be able to look at it as individual. So at this particular layer, at this particular instance here, we actually have one clockwise movement and one anti-clockwise movement. Okay, so this is what we have for this. So that's why if you want to solve moments on the left hand side of the rod, you look at it as an individual. Just look at this layer as if it's only one rod. Balance at point C, you have one clockwise and one anti-clockwise movement, and just solve it like question 1, 2, or even 3 and 4. Okay, likewise for the rod on the right hand side. If you want to solve the rod on the right side, just look at this rod as a whole. Just treat it as if it is like question 3 or question 2 or even question 1. Okay, so this is how we approach this type of multi-layer beams problem. Okay, so now let's look at solving this question. Okay, the question look at it as find the tension in the force AC. Okay, tension in the string AC, sorry. Okay, same I mentioned before. Okay, the forces experienced on the string AC is actually by the force, is all the accumulated force at the lower layer. So there's actually a total of 2 Newton here and a total of 1 Newton here. Okay, so that's why the total forces experienced in the string AC is just a simple of 2 plus 1, 3 Newton. Now most of the students will actually do your answer this way, but one of the common mistake that students need to remember for O level, you'll find that the answer here has to be in 2 or 3 SF, so it's best to have it as 3.0 Newton. It's just for presentation purpose. Okay, so 2 or 3 SF, they will be best. Find the distance at X, find the distance at X. Find the distance of X at the supporting ring at the end of the rod A. X, find X, I need to know this. So the easiest way or the approach to look at it is you look at this rod AB. Okay, so when you look at rod AB, you will find that the moments due to the rod, the moments on the rod AB is due to the forces on AB. So you have one forces which is 5 Newton, and if it's balanced on point at this location, at the pivot here, B will experience the 5 Newton on B will actually pushes the rod and it will generate a clockwise moment. Okay, oh sorry, my mistake is the force on B is 1.5 Newton, not 5 Newton. Okay, 1.5 Newton, and if the moment generated will be a clockwise, okay, I label it at 1.5 Newton, M 1.5. Okay, as for the point A, the force we are looking at is a total of 3 Newton, and it will actually generate anti-clockwise moments about the pivot. Another misconception that we have is based on the picture, it looks like maybe this point might looks like it's in the middle of the rod AB, or maybe slightly less than that, but we can't really show it's like 15 cm middle of the rod, okay, until we really look at it. So one of the common way that we look at it is we label it X. Okay, so if this is X, the whole rod is 30 cm. The other side of the rod will actually be like, it will be 30 minus X. Okay, so this will be the length of the right side of the rod, so it will be X, the other side will be 30 minus X. Okay, in terms of algebra. So you look at the moments, we have the force needed, we have the perpendicular distance that we need, then we can start solving it using principle of moment. Okay, so for this time round, you'll find that for clockwise moment, it will be the force 1.5, distance will be 30 minus X, as I mentioned. Then the anti-clockwise moment will be 3 Newton, and the distance given will be X. Okay, so you have a simple linear equation. So what you need to do is, after substituting all this, you expand it just like normal simple mathematics. After that, you solve for the X, which is like 3X plus 1.5X, you get a 4.5X equal to 45. Then after that, you solve for X, which is 10 cm. Okay, which is the final answer. One thing to take note is that for most of the question, or all the question 1 to 6, we actually make a point to say that perpendicular distance is actually the perpendicular.